Hi guys, welcome back to another class, I guess. So in this video, we're going to be looking at what bearings are. So let's jump straight into the video, right? What are the types of bearings? So there are two types of bearings. One, true bearing, and two, compass bearing. Right, now before we look at what these two types of bearings are, we need to understand what is a bearing. So in the context of trigonometry, a bearing is essentially a tool that is used to give directions to people. So you go south, go north, go west. So it's basically using directions to tell you where to go. So that's how they use it in trig, and that's not its general meaning, because you might have thought it's those bearings in the, what do you call, to help rotate things, but no. True bearing, compass bearing. So what is a true bearing? As the name suggests, true bearing consists of numbers. Yeah, the name doesn't suggest that. The true bearing just consists of three digit numbers. Like, it has to be in a three-digit form, so it has to be like 060 degrees true. So that's how your answer should be looking. You write the value, you write the degree. Let's say if it's less than 100, right? You write a 0 in front. 060 degrees true. Yeah, that's how your answers go. And compass bearings are, what do you call, bearings that take the form, they actually give you the compass direction. So this is more main, like, you could get it from the word. So compass bearing, the answer would look like north 30 degrees east, something like that. Okay. um One sec. Okay, so these are the two types of bearings. Okay. Compass true bearing and compass bearing. Now let's go into some example questions, because we understand this, don't we? Let me just show you how you graph these types of bearings. Draw a coordinate plane kind of thing. North, south, east, west. Now, how 060t would look like is you start at the north point and you go 60 degrees south and you construct your line there. Got it? Same way for here. They're both directions, but different forms of calling the directions, okay? We know north, south, east, west. It's always good to label them. And north 30 east. So what north 30 east means, we're looking at the north and the east plane. So the north and the east plane. And while looking at that, we're going 30 degrees from north. Okay, so that's this. Now let's say if it was north 30 west, we look at the north and the west and we go 30 to the west. Okay, that's bearings in a nutshell. Let's look at some sample questions now that we understand the topic. A ship sails 170 kilometers on a bearing of 210 from port P. How far directly south of the port is the ship? Right, how do we tackle this? Is a very simple question. So essentially, whenever you have a bearing question, I always draw a coordinate plane. Okay, with this drawn, we know that a ship travels on a bearing of 210. So we have to go 210, so that's 90, 180. So 210 somewhere around here roughly. You do know your diagrams don't have to be like, what did I do? I messed up. Okay. Your diagrams don't have to be too detailed or too accurate, like, because it's just for your rough understanding. So that's 210. What do they say? Travels 170 kilometers at this bearing. So we can label this 170. Let me just reduce it there. After labeling it that, the question states, yeah, that's port P, label that too. How far directly south of the port is the ship? How far directly south? So directly south is the ship. So we can draw a line here. We got ourselves a triangle, and we are asked to find this angle, angle x, and we know that this is 30 because this whole thing's 210. So, and this is just 30. Okay. With the understanding of this, we can go and put our, what do you call it, right angle trig concepts to use. Where is that? Yep. So we have one angle, we have the opposite, and we have the adjacent. So what's the ratio? Yeah, it's cos. So put it in. Cos 30 is equal to x over 170. Then it's 170 times cos 30. Putting that into your calculator should give you this distance to be 147.22. And yeah, put kilometers, and that's your answer for this question. Now let's look at one more question before we go, okay? This question, let me zoom in a bit. Okay. Yeah. Chris is out bushwalking. He walks east 3.9 kilometers and then turns and heads south for 6.1 kilometer. After taking some photos, he walks straight back to his starting point. Construct a diagram to show relevant data for Chris's journey. So this diagram should be fairly simple to draw because we have all the information we need. Let's draw the plane first, coordinate plane, and then he walks east for 3.9 kilometers. So using a different color, east for 3.9 kilometers. Then we can label that 3.9. Then he heads south down for 6.1 kilometers. Yeah, no, not good drawing. 6.1. And then he heads straight back to his starting point. So that's straight back. Okay. So they're asking us to find. Yeah, that's the first question. The first question just wants us to draw this. We can label origin if we want. Now, what's question B asking us to do? Question B asks, calculate the distance Chris walks back to his starting point, answer to one decimal place. So calculate the distance Chris walks back to his starting point. So they want us to find this angle as we expected. So that angle, let's just label it as angle. Why am I wasting time deleting everything? That angle, angle x, let's go find that. Do we have all the information we need? Yeah. Do we have an angle? No, but we can use Pythagoras, right? So 3.9 squared plus 6.1, is it 6.1? Yeah, plus 6.1 squared is equal to c squared. So then c in essentiality is just 3.9 squared plus 6.1 squared. So putting that into your calculator, which I shall right now, should give you root 3.9 squared plus 6.1 squared. That should be giving you 7.2 kilometers rounded to 1 dp. That rounded to 1 dp. So to answer this question to 1 dp, 7.2 kilometers. Now let's look at the final question the question's asking us today. I guess we can delete all this because, yeah. So the final question, give the compass bearing for Chris's return walk. Round the bearing to the nearest degree. So give the compass bearing for Chris's return walk. Right, so here we can go and draw an other compass and we can rotate this way. They're asking us to give the compass bearing, okay, for Chris's return. Right. How do we do this? Wait a second, guys. I'm thinking because I don't do these questions before and then attempt them. So give the compass bearing for Chris's return walk. Round the bearing to the nearest degree. Okay, we have 3.9. Let's check again. 6.1 and that. Oh yeah, sorry, I'm dumb. I guess we can just go find this angle if we want. Sorry guys, sorry for the delay. Yeah, I was acting stupid. So we can find this angle. Let's label this angle theta. So angle theta is equal to, what is angle theta equal to? What do we want to do? Sine, cosine, whatever. Let's just choose these two sets because they've given it to us already. Opposite, adjacent. So tan. So tan theta is equal to 3.9 over 6.1. And then theta is equal to tan inverse 3.9 over 6.1. And us doing that should give us, let me put it in my calculator again, 3.9 over 6.1. That should be giving you 32.59 degrees rounded to 2 dp. But they want us, yeah, let's just go store this into a calculator for now, right? Now, they want us to give the compass bearing for Chris's return walk. So what's a bearing? The bearing is, in essentiality, is whenever you start from the north point and you go all the way around until you hit the line, until you hit that line. So the bearing is this, not that bit, not theta, but that angle. So to find that, I guess because we know theta, that's just 360 minus theta. So 360 minus theta, which is this, which I stored in my calculator, would give me 360 minus answer is 327.407 blah blah blah. But they want the answers to the nearest degree. So to the nearest degree, press that degree symbol on your calculator, which is next to the sine symbols and stuff. And to the nearest degree, it's 327 degrees. If they ask to the nearest minute, 327 degrees, 24 minutes. And if they ask to the nearest seconds, 327 degrees, 24 minutes, and 26.71 seconds. So guys, this is bearings in a nutshell. Hopefully you understood the topic, and I'll catch you in the next one.